Computers, much like any other piece of technology, need periodic upgrades for a variety of reasons. As user requirements evolve over time, so too must the hardware and software that support them. Upgraded software packages often demand new hardware capabilities, while new hardware components can significantly enhance performance, providing users with a smoother and faster experience. Moreover, any changes made within the computer system may also necessitate the upgrading or replacing of various components and peripherals. Thus, it's essential to research the effectiveness and cost implications of both upgrading and replacing parts to ensure that the right decision is made. When considering a motherboard upgrade or replacement, it's crucial to understand that this change might require additional component replacements. For instance, if you switch out the motherboard, you may also need to replace the CPU, the heatsink and fan assembly, and possibly the RAM. Furthermore, a new motherboard must fit within the existing computer case, and the power supply must be compatible. To begin the motherboard upgrade process, start by carefully moving the CPU, along with the heatsink and fan assembly, to the new motherboard, assuming you intend to reuse them. It's generally easier to work with these components outside of the case. Make sure to work on an anti-static mat and consider wearing anti-static gloves or a wrist strap to prevent any potential damage to the CPU. If the new motherboard requires a different CPU or RAM, this is the opportune moment to install those as well. It's also essential to clean any thermal compound off the CPU and heatsink before applying a new layer once the components are secured in place. As you prepare for the upgrade, it's advisable to document your current setup thoroughly. Keeping a journal to record how the connections are made helps significantly during the reassembly process. A quick yet effective way to do this is to take photos with your smartphone of how everything is connected. These references can be incredibly useful when putting everything back together. As you embark on upgrading the motherboard, follow these systematic steps. First, record how the power supply, case fans, case LEDs, and case buttons attach to the existing motherboard. Next, disconnect the cables from the old motherboard and remove the expansion cards from the case. Each expansion card should be placed in anti-static bags or set on an anti-static mat to avoid any static damage. Take care to document how the old motherboard is secured to the case. Some mounting screws provide structural support, while others play an essential role in grounding the motherboard to the chassis. Be particularly mindful of non-metallic screws and standoffs, as these can act as insulators. Replacing insulating hardware with metal components could lead to electrical issues. Once you've removed the old motherboard, examine the new motherboard carefully. Identify where all connectors are located, such as power, SATA, fan, USB, audio, and any front panel connectors. Before installation, check the I/O shield located at the back of the computer case. It may need to be replaced with the one that accompanies the new motherboard. Insert and secure the new motherboard into the case, consulting the user guides for both the case and the motherboard to ensure proper installation. Use the appropriate screws, as swapping threaded screws with self-tapping screws could damage the threaded holes, affecting the motherboard's secure fit within the case. It's crucial that the screws are the correct length and that they have the same number of threads per inch. If a screw feels forced, it may be the wrong type, which can lead to issues down the line. Next, connect the power supply, case fans, case LEDs, front panel, and any additional required cables. If the new motherboard's ATX power connectors differ in size, you may need an adapter. Refer to the motherboard's documentation for the appropriate layout of these connections. After securing the new motherboard and connecting all necessary cables, it's time to install the expansion cards. This is an essential step to ensure all functionalities of your computer are restored. Before you proceed, double-check your work. Make sure there are no loose parts or cables that remain unconnected. Finally, connect the keyboard, mouse, monitor, and power supply. If any issues arise, remember to shut off the power supply immediately. In addition to upgrading the motherboard, enhancing a computer's power can also be achieved by upgrading the CPU. Increasing the processing speed through a CPU upgrade can significantly boost performance, but it's vital to ensure that the new CPU meets several key requirements. The new CPU must fit into the existing CPU socket, be compatible with the motherboard chipset, and operate efficiently with the current motherboard and power supply setup. Often, a new CPU may require a different heatsink and fan assembly, which must be adequately sized for the CPU and compatible with the CPU socket. It's also essential to apply thermal compound between the new CPU and the heatsink to ensure effective heat dissipation. Check the thermal settings within the BIOS to monitor for any potential issues regarding the CPU and cooling unit. Third-party software applications can also provide easily readable reports on CPU temperatures, helping you determine if everything is functioning within the normal temperature range. For those looking to enhance cooling further, installing additional fans into the computer case is a practical step. To do this, align the fan correctly to facilitate airflow, either drawing air in or pushing hot air out. Install the fan using pre-drilled holes in the case, with the common practice of having fans near the top expelling hot air and those located towards the bottom drawing in cooler air. Avoid placing two fans close together that move air in opposite directions, as this could create turbulence and reduce airflow efficiency. Once the fan is positioned, connect it either to the power supply or, depending on the fan type, directly to the motherboard. In some cases, upgrading storage devices is also worthwhile. Instead of purchasing a brand new computer for increased speed or storage space, adding another hard drive can be a cost-effective solution. The reasons for installing an additional drive can vary, from expanding storage space and improving hard drive speed to providing fault tolerance and facilitating system backups. Once you have selected the appropriate hard drive, the installation process is relatively straightforward. Start by placing the hard drive securely in an empty drive bay, tightening screws to hold it in place. Then, connect the drive to the motherboard using the correct data cable and attach the corresponding power cable. Peripheral upgrades are also vital for maintaining optimal performance. Devices like keyboards and mice may need to be upgraded due to wear, to enhance productivity, or simply for improved functionality. Ergonomic designs can aid in comfort and may help prevent repetitive strain injuries, making them a worthy upgrade option. In cases where the existing expansion slots or sockets cannot accommodate an upgrade, utilizing USB connections can provide a solution. If there are no available USB ports, consider installing a USB adapter card or acquiring a USB hub to expand connectivity options. Lastly, when upgrading hardware, it's important to consider the power supply needs of the computer. New hardware typically requires additional power, which may necessitate upgrading the power supply. Online calculators can help determine if your current power supply suffices. It's worth noting that some computers, particularly servers, can accommodate dual power supplies for redundancy purposes. This setup allows for one power supply to remain functional while the other is serviced, providing an uninterrupted power supply to the system. Overall, understanding these processes and requirements is essential for effectively upgrading your computer.